In the last video, we played around with some shaders from this guy called xordevs, and in this video, I want to try to kind of deep dive into this shader and try to figure out how it's working. So what we've seen in both of the shaders we looked at is like this pattern. I think we can make it a little bit more sensible if we do it like this. Okay. If this is now a vector 3, and we'll do this kind of thing. Okay, so what do we have now? And then we don't need that. P is the like overall position of the object that we are drawing. Right. Okay. Rx is the x shift. Ry is the y shift of where the, let's say, of the object. And Rs is the scale, Rz, sorry, is the scale of the object. So you can see that here, like we're explicitly subtracting xy and dividing by z. So this is something that he uses a lot. I think it's kind of. Then I don't actually want to analyze this right now. Let's look at the output color instead. So there is some kind of complicated function here. It has to be a vector 4. So we can try to pull out what are the components, because it can be a little bit hard to see. So let's start by making it 0. And then we can say, okay, what should the x be? Okay, there's a tangent hyperbolic, there's an exponential function, then there's some number, and now we finally get like what is a component. So to get the x component, we need to pull out the x component of this guy, which is 1. Then the exponential function and tangent hyperbolic closes. Then there is some more just stuff here. Then we have O, which is also a vector, right? So we need to say, actually, only give me the x component. So now you can kind of see what's happening. So this is actually the red color, right? And we can, if we do a little bit of substitution, that was a very bad substitution. So yes, no, yes. The same here, this line. Let's substitute x with z. And yes, no, yes. Okay. And this should be the, green. And finally the blue color. And what do we have for the alpha? That's also interesting, the alpha channel. That would be out color.w, I think it's usually called. We have tangent hyperbolic, we have this again, now times 0. So it's actually, so this is 1. So the exponential of 0 is 1. So we can just put a 1 here. And then this Lx divided by OW. So this should, when I save it, should yield the exact same picture. It doesn't change anything. Now we can try to play around with it. Like, let's say we just fix this to be 1. It should be red all over, basically. And oh, there's some compilation error that I didn't see. Too much data in type constructor. I wonder why. Right, okay, it's up here. So now still doesn't. So some ice cream not present. Operand. Is it this stuff that is causing the compilation error? Okay. That's all right. Okay, so there's some bug here. X, Y, Z, O, W, O is a vector 4, that's fine. And of course it's because this one actually shouldn't have, that's the LX all the time. We have some kind of missing thing, which is that one. all right. Somehow it didn't work because I made a mistake. What? I thought this should not change anything. Okay, so it doesn't. We have py. Of course, because I forgot to change these values. Because here we see it's the y component is -1. Okay, and the z component is -2. So now we have this again. I feel like I changed something. Maybe we put this one to 0, and it's very bright. Can we do something about that? Probably it's O. If we change it to 2, 1. Okay, let's keep it like that. That's fine. Okay, so what if we change this to 1? Now it's red all over except for some places, and if we change this to 1, it should be green all over, and this to 1 should be blue all over. Okay, so we kind of have the understanding, and if we change this one, it shouldn't be changes a little bit to transparency, but actually doesn't do that much. It might even be better, at least on my screen, if we just do 1. All right. So now we kind of understand that we have some prefactor on the colors. So this vector here is kind of choosing a relative weighting of the different colors. So if we change this, the exponential function will be much larger, which means that the hyperbolic tangent will also be larger. So we should get more green. So it becomes more green. Okay. And if we change this, we should get more blue. I don't know about that, but okay. What if we just do like that? And like, what if we only want blue? Okay, so that's another thing I suppose we should think about, is that we are actually multiplying by the position. So it's changing the color with respect to the position. So if we change this to X, we should see it kind of rotate, the colors rotate a bit. So that's what we see. We change some of them, we'll kind of change how the colors vary across the screen. So that's what this tangent hyperbolic thing is doing. It's changing the color weights across the screen as a function of position, and it's kind of changing the weights of the different colors, color channels in different ways. I hope it makes some kind of sense. It makes a little bit of sense to me now. Then there is this constant factor. So if we change L, it will just change, and Lx in particular, it will change things across the whole image. So that's why, like, if we make it negative, it should become brighter because we have a negative number multiplying in front. So if we have like -1 up here in Lx, it should become much brighter. And if we have positive, it should become much darker. Okay, so that makes sense. And then we have these, the O value. What is that? So now I think we need to start analyzing this. And it's a little bit obfuscated again. So I think let's try to de-obfuscate it. I want to rewrite this for loop. So for float I equals 0, then I should be less than this. And we add, let's just do it like this. We add 1 at each iteration. But there's also the actual post condition, or whatever it's called, in this loop is this statement. So let's add that here, and then we can put that one there, and then it should be exactly the same. It's not the same. It's not the same. It's very interesting. That is very strange. It's not because plus plus does something different. That could not be. So that's fine. And this one is broken somehow. That one is broken. But I really did just copy paste it, so maybe I should do this. Or equal, no, that changed that much. This is very annoying. What if we, is it some weird thing like that? Okay. That is bizarre. That changes things. That also changes something. So I thought that this is basically, well, I plus plus is equal, like it should be, let's try to rewrite it as a while loop. So this should be the same. It's the same. And that means I should be able to do this. That's also the same. Maybe that's the problem. That I don't actually need this to start at 1, I think. Now it's the same. So that was the problem. If I go back and say it starts at 0, it becomes black for some reason. All right, that is strange. That's very strange. So let's see what's going on here. We know that the O is the weighting of the different channels, the weight of the different channels, and it's being updated here. And then we have this here V, which depends on itself. Okay, so V depends on position. We can see from up here. And on L. Now what is L? L is some kind of function that becomes like it starts at a large value. If we like consider the center, then P is 0. So it starts at a large value, then it goes to 0 and then becomes large again. So that's why it's kind of a ring. So actually, if we remove this, we shouldn't see a ring anymore. Okay, just we have done something weird somewhere. Here. So, okay, I'm not sure what happened, but it's definitely not a ring. It's definitely not a ring. What if we do this? It's very dark. I don't know if you can even see it. But it's definitely not a ring anymore. Let's not do that. And if we change this one, I think we'll change the radius of the ring. So it becomes more compact, and if we make it 1, it should become wider. Okay, so that kind of makes sense. So L is a function that starts at 0 or starts at a high value. Here's 0.7, and as we move away from the center, this thing increases, so L decreases until we reach reach 0.7, then it's 0, and afterwards it increases again. Okay, and if we kind of like started at a low value, which is what we are seeing here, it's kind of like an overall shift. That means it actually starts at not 0.7 but 0.4, and it's still at 0.7. Like this is still the, so we can even like say float a ring radius. So that's going to be 0.7, and we have another one that's like the shift. Let's call it the, so what is L actually? Where do we see L? It's kind of like a weird brightness. So it's like let's call it brightness start. Like this. Brightness start and ring radius. Okay. So we can, as we said, we can increase this, make a huge ring, decrease it, make a more compact object. So we can kind of control that. Okay, so that is L. It is kind of like a brightness factor, and it's kind of a function that does this kind of weird, like starts at a certain value, then goes to starts at a high value, then goes to a low value, and then increases again. So here we can even draw it like it starts here, then it goes down, and then we reach some kind of floor, and then it starts going up again. Like that. And it actually keeps going up. Further you get away, it gets more and more. Like that. I probably don't like that. That's okay. L graph. And this is like as a function of the radius, so the distance from the center. It starts at a low value, then, oh no, it starts at, in our case, at 0.4. Then, as we go away, it's because it's kind of a little bit confusing this way to write it, but okay, this is how the graph looks. I'm pretty sure. And this, so this here, start value, this would be, how do we do that? This would be -3 plus 0.7, and this here would be just -3. All right. So far, so good. So far, so good. So what is V? It is something here, like there's so many weird things to think about. Okay. This looks very cool. I'm going to take a screenshot. So what is this? What is this? It's really hard to understand for me. So now, so what is 1 minus L? That's kind of like you invert the graph and you shift it a little bit. So, and then you scale it down. So you squish it. Okay. So now instead of a low value where the ring is, we get a large value. Fair enough. And what if I squish it even more? Okay. And if I squish it even less, we saw it was this kind of weird thing. Great. It's actually a little bit further complicated by the fact that this is a vector. So we basically have two rings, or like two functions. One that starts at starts at different values. So we can do this, and it will change it a little bit. We'll make 10 here, for example. It should really change how it looks in the one direction. And here, doesn't matter so much. So if you make these two values different, it will change the graph a little bit in the different directions. It's really not like a one-dimensional function, it's a two-dimensional function, so it's a bit hard to picture. All right. And so what is this? This is some weird function. But I guess this is where the art comes in. Can I do this? Changes a little bit. Changes a little bit. We do this. Should really be interesting. And now let's remove some else. Okay. All right. Let's not. Actually, what happens if we do 3? Let's want to see it. What if we do a P in here? Didn't change too much. And now I want to maybe this shape up here, like that is super cool. Just like that. So can we make it larger? And maybe I want to focus like a little bit over there. No, that's not how you do it. Like that. This one. Great. Just a little bit higher. Now zoom in a lot. Too much. And actually move me a little bit more. A little bit more. A little bit more. As well. Maybe even a little bit. Maybe even 2. Okay. Can we increase how much the pattern changes? And also, this value is hard to remember. I'm not going to change that. All right. Let's do some changes here. Let's see what happens. Probably that doesn't change too much. We do 10. Okay. All right. It looks interesting. There's not so many details, so I'm actually not thinking it's that cool. All right, let's zoom out again. All right, as a bit of digression. So we have here the V, which is some weird function. Let's return it to what it was before. Some weird function like that. And then we have O, which starts with 1. And what's the O? The O was the scaling of the colors. And if we do negative, it's just gonna that's because it's gonna make some of the color channels negative, which does this weird thing. So we don't want that. If we change it by a lot, the color should be more faded overall because it's probably starting just getting an overall higher value. Okay, let's now look at this here loop. We loop some number of times. We then change V depending on V itself. And this is like you can do this. Okay, it makes a different kind of picture. What if we do that? Probably makes it a little bit. No, it's fine. Yes. How about this? Oh, like that. Interesting. But this is a good choice, I think, that he made. Huh. All right, so we have that. Actually, what is the problem with this? Now it's like a function that doesn't change, and like with position. So this one doesn't change. Actually, I have no clue how to understand this. I have no clue how to understand that. It's maybe the way to understand it is that it's adding finer and finer detail. Because what we have in here is we have some things that vary with position in a way, because this V thing is kind of it's some complicated function of position. So we multiply by I and it becomes larger and larger. So this cosine function will vary faster and faster. We also add this kind of thing, which varies faster and faster. And here's the time, which is some offset. So the thing we're adding will be varying faster and faster, and we're also dividing by I, so it will be a smaller and smaller scale. So you can think of it as more and more detail. And I think that's true because if I do 80 here, I will go up to like scale of 80. Well, I have so many fine details, you cannot even believe it. So yeah, look at that. That's kind of interesting. Let's see, what did we have before? We had like -2, -2. So that's how you can get more details. It is also interesting to note that the overall brightness of the image has decreased. But you get these very cool patterns. And why is that? That's because this one also increases in value. So maybe if we do that, make it a bit brighter. Okay, I like that. I like that. Let's actually do a screenshot of that because this one is really cool. Maybe we zoom in just a little bit, like that. Sure. And I even like this one so much that I think I'm going to make a copy of this this particular state of this of the shader. So let's say cool XOR snapshot. So we have that. All right, let's just zoom out again so we can see everything that's happening. And that explains that. Let's go back to 8 and 2 here. Okay, so this is like some function that has more and more details. So that's good. Here we have some kind of weird combination. I'm not sure this necessarily makes a lot of sense. What if we just do XY, XY, for example? changes the colors a bit. So it's kind of affecting here red and alpha in the same way, and green and blue in the same way. So that's interesting. That is interesting. X about y, x, x, y. I don't see a big difference. That's fine. And then we have this. So because this v function is so complicated to think about what it actually is, it's very hard to fully understand what's going on here. I can imagine it took a lot of trial and error to get something nice. But maybe with experience it becomes easier. And what if we change this, we should, like this guy, make it larger, then overall we should get a less bright image. So that is what we see. But yeah, so actually we'll change how much things vary, because we will still get some points where this one is negative. And so 1 means we'll get full brightness. Okay, what if we do 20? 20? All right. And if we do this, we should kind of, okay, that makes sense because we get some negative values, I guess, but can we do it just a little bit? That's interesting. So we just get negative values. We really want to avoid negative values. But what if we say, okay, you can have a negative value, but we actually do the apps here, then it doesn't change too much. Of course, it changes some details, but it's not that interesting. This function is interesting. But again, why exactly it works that way, I don't know. All right. And if we do something else like sine hyperbolic, it just completely explodes. What if we did that here? No, it's not interesting. All right. Can we, so we kind of have a bright pattern here and a bright pattern here, and if we did change that one, we see that that is kind of all that is left. I want to try to move that. That'll test whether we understand what is going on. So to do that, I think, what if we just swap this guy? What happens then? Nothing. What if we say minus? Nothing much. So what if we say vec2 px minus? I think that should do it, because that's effectively swapping like the direction for v only. So that's great. That's great. Go back to here. So we can kind of change how this function works. Maybe we can squish things, change the shape a little bit. This function. But actually it would be interesting. Can we just see what v is? And we can do that. Can actually do that, because we can just do this vector 4 v, and let's say we don't want green, so let's do it like that. Okay. Is it ever negative? probably it is. So what if we do this? Okay. Oh, you know what? We can do something else. Let's say minus v of x, and this one is just v dot x. Visualize it one at a time. Okay. So the x component, remember it's two functions, so it's very complicated, looks like this now. And if we change, let's just do something like this, so I don't have to write it too many times. If we change it to y, you can see it's just pretty much rotated. It's a little bit different in the shape because we didn't use the same value here, but I'm sure if we change it like that, it will be, should be exactly the same, just rotated. So that's interesting. What if, of course, if we change them both to the same thing, they won't be interesting. So, but we have this function. Okay. Can we change how it works? Let's just do dx again. Can we, for example, make it change value more rapidly? Like, what if we do this? Then, okay, maybe it's maybe we do like 1 plus, you know, a little bit of change, maybe 0.2 actually. This should have been a plus. Like that, we cannot see much difference. That did a little bit. That did a little bit. But if we do it like that, it changes the value in some places, and we can do like that. Okay, so this is like one way we could get more interesting behavior. What if we just do like p, so 1p times 1 plus 2.5 and p times 3. That's undefined value, it says. Okay. Let's try to enable the full thing again. Oh, so that's weird. Can I just do it like that? Like that. So I think it's because it's also changing here, so maybe we don't want to make it too complex in the beginning. What was the original? It was just, I think it was just p. Yes. Still though, some kind of change could be interesting. Let's plot the function again. Let's do, does that matter? Let's change it a little bit like that. What if we do 0? So that, then we have almost the same thing, but it does produce a very different image. Maybe not very different, but you can see that the details are kind of different. So, and it's really, you cannot really understand, at least I cannot understand how this particular small change between this function and this function is creating this huge like effect here. But I think you just experiment with it until you find something you like. Okay, so like it's super hard to understand the effect of V in detail. But V should probably be a kind of simple function because it's used in a loop. It's like complexified in a loop later. So if we made it too complex like that, this becomes very noisy already from the beginning. You also want like some smooth shapes, I think, for the picture to be aesthetic. So this thing is this is interesting technique. Loop some number of times, and each time add something with a higher frequency to get a higher frequency and smaller scale to get more fine details. At this point 7 here, I don't think we played with that, but it's funny that that changes the color so much, and in a really bad way. Like the green, I mean, I guess it kind of looks like the Northern Lights, but I don't like it so much. Maybe if we go back to this one and we do like 3. No, we still get some green. But all right, I think it's going to do it for this video. So we did a bit of a deep dive into this shader, trying to understand how it works. And maybe we can try to create something like that in a future video, but we'll see. So until next time, bye bye.